Hello everyone, in today's video we are going to cover section 9.3, altitude on hypotenuse theorems. After studying this section, you'll be able to identify the relationships between the parts of a right triangle when an altitude is drawn to the hypotenuse. In my figure to the right, we have a right triangle, triangle ABC. When I draw in altitude CD to the hypotenuse, side AB, it creates three similar triangles. The smallest triangle, triangle ACD, is similar to my medium-sized triangle, triangle CDB, which is similar to my largest triangle, triangle ACB. All three of these triangles will be similar by AA similarity. Now, when we have these similar triangles, it creates mean proportional relationships between some of the same sides. So if first I have triangle ABC similar to triangle ACD, which is the large triangle similar to the smallest triangle, I can notice that side AB, which is the hypotenuse of my large triangle, over side AC, which is the hypotenuse of my small triangle, would be equal to side AC of my large triangle, which is still AC of my smallest triangle. They're the same side, but that's now the short side of my largest triangle over AD, which is the short side of my small triangle. So hypotenuse over hypotenuse is equal to short side over short side. Or AC squared, because it's the same side squared, is equal to AB times AD. Therefore, AC is the mean proportional between AB and AD. Next, we can look at our large triangle and our medium triangle. We can notice that side AB, the hypotenuse of the large triangle, over the hypotenuse of the medium-sized triangle, so CB, that's equal to the long side of the large triangle, side CB, which again is the hypotenuse of my medium-sized triangle, over the long side of the medium-sized triangle, which is side DB. So that would be hypotenuse over hypotenuse is equal to long side over long side, or CB squared is equal to AB times DB. Therefore, CB is the mean proportional between AB and DB. And lastly, looking at my medium-sized triangle and my small-sized triangle, these triangles would be similar because they're both similar to the big triangle. Therefore, using the transitive property, I could say they're similar to each other. The side that they share is side CD. So we can say the short side of the small triangle, side AD, over the short side of the medium-sized triangle, side CD, is equal to the long side of the short triangle, which is CD, over the long side of the medium-sized triangle, which is side DB. So AD over CD is equal to CD over DB, or CD squared is equal to AD times DB. Therefore, CD is the mean proportional between AD and DB. Now, these illustrations prove three closely related theorems, which we'll present as one theorem. Now, these three theorems will be summarized into parts A, B, and C of Theorem 68. So if an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the given right triangle and to each other. The altitude to the hypotenuse is the mean proportional between the segments of the hypotenuse. So if h is the altitude, then that's the mean proportional between x and y, or h squared is equal to x times y. And then either leg of the given right triangle is the mean proportional between the hypotenuse of the given right triangle and the segment of the hypotenuse adjacent to that leg. So we could say y, which is a short side, over a, which is a hypotenuse, is equal to a, which is a short side, over c, which is a hypotenuse, which would simplify to a squared is equal to y times c. And we can also say that x over b, which x is a long side where b is the hypotenuse, is equal to b, where b is the long side, over c, where c is the hypotenuse, or b squared equals x times c. Now, parts B and C of Theorem 68 can be summarized as follows. H squared is equal to x times y, so the altitude is equal to x times y. B squared is equal to x times c, so this segment is equal to x times c. And then A squared, so this segment here is equal to y times the whole segment c. Looking at our sample problems, we have problem 1. If AD equals 3 and DB equals 9, find CD. Now, there's two ways that we can solve these problems. We can remember the rules that we just learned. H squared is equal to x times y, B squared is equal to x times c, A squared is equal to y times c, or we can set up proportions based on their relationships. I personally like to set up the proportions Now, if we set up a proportion, then I would have 3 over x, because 3 is a short side of my small triangle, where x is the long side. That's equal to x over 9, because x is the short side of my medium-sized triangle, where 9 is my long side. Now I could use means extremes product theorem to multiply this out. So 3 times 9 would be 27. X times x is x squared. Solving this for x, I'd take the square root. So x would equal plus or minus 3 root 3, because I can simplify root 27. Now I know that I don't want the negative value here because I can't have a negative side length, so x is simply positive 3 root 3. Now, if I want to use my rule, this rule would have been h squared, because x is the altitude, is equal to x times y, where h squared would equal 3 times 9, h squared is equal to 27, and then I'd take the square root, and I can see that both ways work. They will get you the same answer. Looking at problem 2, we have if AD equals 3 and DB equals 9, find AC. So here I'm going to set up a proportion. AD is my short side, so that's 3 over x, which is the hypotenuse. So I have short side over hypotenuse of my small triangle. That's going to be equal to the short side of my largest triangle, which is x here, and then the hypotenuse of my large triangle, which is AB, which is 3 and 9, which makes 12. So now I can use my means extremes product theorem to multiply this out. So x squared would equal 36. I'll take the square root of 36. So x is just going to be positive 6, because I'm going to throw away the negative value because I can't have negative side lengths. Now, if I wanted to use my rule, I could use b squared, where AC is b squared. That's equal to x times c, where AD would be x, and then AB is my c value. So x times c, where x is now 3, and then c is now 12. And again, I'd get b squared is equal to 36. Taking the square root would give me 6. So we can see again, both ways work. You just need to find the way that works best for you. And lastly, problem 3, if DB equals 21 and AC equals 10, find AD. So here I'm comparing my small triangle, triangle ADC, with my large triangle, triangle ABC. So I'm going to set up my proportion of AD over AC, which is the short side over the hypotenuse. So x over 10 is equal to the short side of my large triangle, which is AC, which is 10, over the hypotenuse, which is AB, which would be x plus 21. Now, when I use my means extremes product theorem to multiply out, 10 times 10 is 100. X times x plus 21 would look like this, where I need to now distribute the x inside. So 100 is going to be equal to x squared plus 21x. I'm going to subtract 100 from both sides, so I can now factor this equation. So I'll get 0 is equal to x squared plus 21x minus 100. Now, factoring this, I'd have factors of positive 25 and negative 4. So x plus 25 and then x minus 4 will equal 0. Setting both these factors equal to 0, I'll get x is equal to negative 25. And then x is equal to positive 4. I'm going to throw away the negative 25 value because I can't have negative side lengths. So AD is 4. In today's lesson, we learned if an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the given triangle. The altitude to the hypotenuse is the mean proportional between the segments of the hypotenuse, and either leg of the given right triangle is the mean proportional between the hypotenuse of the given right triangle and the segment of the hypotenuse adjacent to that leg. That's a wrap on today's video. We'll see you in the next one.